5, 4, 3, action.
Hey guys, we are on week 3, part 1 of this distance learning adventure. Your last week, by the way, so congratulations on getting this far. So what we're going to talk about today, 3 topics. The first one is simplifying radicals. Now in simplifying radicals, I like to use the analogy, I know Mr. Penner does too, of go fish. And so we're going to play little kid go fish where we only need 2 of a kind. We don't want to play pro go fish. So we have the square root of 81, and the first thing we want to do is factor it. And we're looking for pairs. Now you might say, okay, I know 3 goes in here 27 times. 3 will go in there 9 times. And then I have a pair of 3s. And so my square root of 81 can look like 3 times 3 times 3 times 3. Now I'm looking for pairs to make stacks outside my hand. This is my hand of cards. So I pull a pair of 3s out, make a stack. I can pull another pair of 3s out, make another stack. Now notice there are no numbers left inside the radical, so my hand's done, game's over. This is equal to 9. Now some of you might have said, well, I didn't see it quite this way, Wheeler. Well, that's okay. See it how you want. If you saw a 9 and a 9, now I said you're looking for pairs. It doesn't matter if they're prime or not. This is perfect. I got a pair of 9s. I'm done. Now this one's a little trickier. One thing I like to do when I don't recognize a factor, I add the digits together. So I've got 5 and 7, that's 12. Now, you have a rule for 3 and 9 that works the same way. If you add the digits together and 3 or 9 goes into that number, it goes into the original number as well. 9 won't, but 3 does. So if I factor a 3 out, I end up with 49, and that's pretty sweet because I get my pair of 7s. So we don't even have to do the arrows. We can see it right here. I've got a pair of 7s. So this is going to give me 7. The 3 goes back into the hand because it doesn't pair up. So 7 root 3, and I'm done. Now 180, that's a pretty nice one. Looks like 18 and 10. And then I'm going to factor this one. I've got a 2 and a 9, which gives me a pair of 3s. And here I've got a 2 and a 5. Now you got to be careful. They kind of got scattered around. So you may want to rewrite this one as 2, 2, 3, 3, and 5. I got a pair of 2s, I make a stack. I got a pair of 3s, I make a stack. And the 5 is left inside, so 3 times 2, I get 6 root 5. And I've just simplified the radicals. Okay? So we're going to use that in the next set. We're going to solve equations. Let's look at this one first. We're going to solve equations by taking a square root, which that's where this application of simplifying radicals comes into play. So in order to solve, I take the square root of both sides. And this is a horse I think I've beaten pretty well to death. Anytime you take the square root, you have to consider plus or minus. And so we have plus or minus root 36. And so I get x minus 2 is equal to, now 36, that's like the square root of 81. I got a pair of 6s. So I have negative x minus 2 equals plus or minus 6, add the 2 to both sides. I'm going to get some nice solutions. If I've got positive 6, positive 2, that's 8. Negative 6, positive 2, negative 4. So I have 2 rational solutions out of that example. Let's look at one more. So x plus 4 squared is equal to 27. That's not a perfect square, so we can expect an irrational answer out of this one. So again, take the square root, both sides. Beat the horse up a little bit more. So I have x plus 4 is equal to, plus or minus. Now 27, that's a 3 and a 9. So that's 3 3s. So I'm going to get 3 root 3. This is actually easier because when I subtract 4 from both sides, I don't have to combine anything. I've got negative 4 plus or minus 3 root 3. We want exact answers. And since that's irrational, we cannot combine them. So that is your solution for that equation. Okay, the next topic we're going to look at is completing the square. Now, in completing the square, thank you, Mr. Penner. In completing the square, we're going to first look at x squared plus 6x plus c. Now, I'm looking at this in terms of ax squared plus bx plus c. We're going to keep a equal to 1. So we're trying to find a c value that will make this a perfect square. So we're trying to figure out how many of these little units we need to make a perfect square. So I have my x squared, and here are my 6x's. So if I start with these all on the bottom, in order to make a perfect square, I need to move enough up here to the right that I've got symmetry and I can see a square develop. And I think if you look at this, it's pretty obvious. If I fill this in, I've got a perfect square. And then the idea is, how many of these little tiles do I need to put here to make a perfect square? Well, that's 3 by 3, so I'm going to need 9. Now, the way we can get this, if you look at this visually, I took my b value 6 and I split 6 in half. And so I took 6, I divided that number by 2, and I got 3. Now that 3, that represents the dimensions on each side of this. And so if I square that, I get my c value. That's how many little tiles I have to add on to make this a perfect square. So my perfect square looks like this: x squared plus 6x plus 9. And if I want to write this in factored form, I've got x plus 3, x plus 3, and you might be asking yourself, can I write this as a square? You sure can. Notice that 3 shows up in a lot of places. All right, so let's take a look at another one. So let's say that we have x squared minus 12x plus c. So what does c have to be? Well, we still take that 12 and divide by 2. And that's going to give us 6. And then when we square that 6, we're going to get 36. And so c has to be 36. Now notice I could keep the negative with this, negative with that. With that, c is always going to be a positive value, regardless of your b value. And so I'm going to factor this, and I've got x minus 6 quantity squared, perfect square. And I guess I should have put this up here. Okay, so let's look at one that's a little bit tougher. X squared minus 7x plus c. Now, you might be saying, okay, I'm going to divide that by 3, or excuse me, divide that by 2, and I'm going to get a negative 3.5. I wouldn't go there. I like this so much better. I don't know what 3.5 squared is, and I really don't care what it is, because I know 7/2 squared is going to be 49/4. And so c is equal to a positive 49/4. And so I've got x squared minus 7x plus 49 over 4. And then in factored form, that's going to be negative. And I just write this number down, 7 over 2. And I'm done. So let's look at one more. Let's go with another odd. And we're going to make this odd positive this time. You're going to see C is still going to be a positive number regardless of the sign on B. And so C is equal to 11 over 2 squared, which is equal to 121 over 4. And so factored form, I'm going to have x plus 11 over 2, quantity squared, Wheeler out. Is that okay?
Absolutely. I haven't stopped recording it either.